Hello everyone. Today I'm going to demo the Milestone deployment, and the team members are Vineet Paul, Manav Verma and Shay Sheikh. So initially what we have done is we have maintained a local Jenkins server which will manage all our builds. So whenever we make a commit, we have written a post commit hook such that it runs before making the commit and checks if the build is successful. If it is successful, then the commit goes through. If not, the commit is reverted. So that we have written in our post commit file. So as you can see, it polls the Jenkins server, and if the result is success, then it goes ahead, or else it does a reset, hard reset, moving a commit back. So let me demo for you a commit, and I'll open the Jenkins server in the background. So you can see currently there are 6 builds, and when we do a commit, there will be a 7th build which starts. Oh, sorry, there's 7 right now. It just refreshed. And let's make a minor change. And let us add the file. And now we are doing a commit. So as you can see, it is getting a build status, and in the background, a build has already started for us. So the build has become successful, and so the commit also was made. Now, what we have done is we have written a Python script which generates for us 4 servers. One of them is a production server, one is a canary server, one is a Redis server, and one is a proxy cum autoscaling server which handles the proxies amongst the productions and the canary, and also handles the autoscaling functionality. So first let us run that particular file. So this takes a short while, and I'll pause the video. So as you can see, 4 instances have been spawned, and our proxy is running at this IP with the following port number. Let us also view our inventory file which was created by this Python script. So this is our inventory file. It has 2 servers, one of them being the production and one being the canary. It has a Redis server and the proxy server. What I would do now is I would make a push, because of which it will initiate an Ansible script which does provisioning on all the 4 servers. So it deploys our code on the production, the canary and the proxy server, and also installs Redis on the Redis server and starts the service on it accordingly. So I have put that particular script in the pre-push file. So this is the Ansible script. So there's a single playbook which does all the related functionalities. So now let us make a push. So the push is made and the Ansible script already started running in the background. As you can see, our Ansible script has started and it is first trying to connect to the servers. So this whole setup takes a while. Meanwhile, I'll show you my Ansible scripts. So this is the structure of our Ansible scripts. The main playbook is a deploy playbook, and it calls tasks which are written in the tasks folder. So there are certain sets. So install dependencies installs all the related dependencies such as Node and Redis and Forever on the servers. And coming to the configure AWS, installs the AWS client so that our proxy server during autoscaling can spawn additional AWS instances, and so on and so forth are the other playbooks. Currently Java is being installed. I'll pause the video over here and resume when the Ansible finishes its to completion. As we can see, our Ansible script has run to completion, and our code is deployed on the production canary, the proxy, and the Redis servers. So now when we run our proxy server, we should notice the output hello world as it is present in our main index.js file. So let us visit the proxy server at the port 8081 as we had seen initially. So this is the IP of the proxy server. As you can see, we get a hello world message, and as this message is coming from the canary server, so we get it prefixed with the canary. And we have implemented load balancing such that 75% of the traffic is sent to the production server and 25% is sent to the canary server. So right now we have gotten the canary server, the output from the canary server, and if we reload the page, we get it from the production server. If we reload it again, it's still the production server. If we reload it again, the production server. But if we reload it now, we get the canary server. So 1 out of every 4 requests is sent to the canary server. And this is how we have implemented load balancing, which is the code of which is present in the proxy server. Now let us move to monitoring the servers so that if any time there is an excess of memory or CPU usage, a message is sent to us. And also, in case of a production server, it sends an alarm to the autoscaling server to spawn a new instance for it. While in the case of a canary server, the canary server gets disabled whenever an alarm is raised. Coming to alerts. Let us first open the console of the production server. Now we are in the production server, and let us start the monitoring service. So we have written a script which does the monitoring for us, and this is the script, and it checks if the CPU and the memory levels. If CPU stress is greater than 55, then it raises an alarm, and it sends an autoscale message to the autoscale server to create a new instance and sends another GET request to provision that particular server. So similarly happens when the memory goes above a particular threshold value. So what we do now is we run this particular script in the background. That script is running in the background for us. And now we will introduce a particular kind of stress so that the memory gets overloaded. So that we'll do by using the stress command. Stress has started, and now we would notice that a server has already been dispatched for us. We notice that we have received a message on our phone just because the memory had crossed a particular threshold. So if we visit that particular site, let's refresh the page once. My page is taking a while to load. Yeah, as you can notice here, a new message has come up, and if we click on that message, then we get the details of that particular message. So as you can notice, it is said memory overload message was sent to the particular user. And also, if we notice our AWS account, we would see that initially there were 4 servers which were running, and there will be an additional server which would have been created for us. Let's refresh this. Yeah, so initially there were 4, and now there's a 5th server which has been added that is still in the initializing state. And also, as we had seen in the script, we also send a GET request to provision that particular server. So that server is currently also being provisioned in the background by the auto-scaling server. So this is how we implemented monitoring and initialized and raised an alert request whenever the memory or CPU got overloaded. And also I have shown you how auto-scaling was done. So whenever the thing got overloaded, we see a new server getting spawned, and in a while that would also start responding to requests. That could be seen when we visit our Redis server, so that we will see another IP entered into the server list. So let me open the console of the Redis server. So now in our Redis server, we can see by logging into the Redis client that if we look at the server list, we would have 3 IPs. The new one, that being the one which was just spawned by the auto-scaling process. So as we can see, we have 3 IPs. And now, if we again visit our proxy, we notice that the requests are still being served. So thus, this is how autoscaling was implemented in the case the production server being overloaded. Now there's also a case where we can set a feature flag. So what we would do now is, as we are currently on a Redis server, we would set variable called new feature and put it to false as of now. So whenever we give a route of new feature, we get the message feature is not available. But when we accordingly set the value to true, we get a message, experience your new beta version. So thus, by toggling the flag value, we have also enabled the property of adding and removing features to our particular server. Coming to the last point, which is the canary releasing. So I had already shown you how I was routing 75% of the traffic to our production server and the 25% to our canary server. You can view that again. So now our canary server is serving us. If we reload it again, then our production server will be serving us. We roll it again, still the production, and the fourth time again the canary. So we have divided it as 75-25%. The last case which I have to show for now is that if the canary gets overloaded, it will raise an alert message, and then none of the requests are routed to the canary server. So let us see that happening. Now, let us log in to the canary server's console and manually raise an alarm from there, so that we would notice that whenever an alarm is raised from a canary server, its IP gets deleted from the Redis server, and thus none of the requests will ever be sent to the canary server. So this is our canary server's IP, and we've logged into it. What we do now is we will raise an alert alert was successful. So now when we go and look at the server range, we see that the canary server was removed. And if we again visit our proxy server's IP, we get hello world, and no matter how many times we reload the page, we still keep getting hello world, and the canary server never responds. So this is how we stopped the routing of our traffic to the canary server. So whenever the alert was raised from the canary server, we deleted its IP from the server list. And this is all I had to demo for our milestone of deployment. Thank you.